Hi, this is Giridhar from eMath. As eMath, this video series is an initiative of a free chapter-wise revision for all SSLC students of Karnataka. In this video, let's revise the chapter Triangles. Let's get started. Okay. So chapter 2 Triangles. In this chapter, we have a concept called Similarity of Triangles. So let's see what is that. So two triangles are said to be similar if their corresponding angles are equal and their corresponding sides are in the same ratio, right? So there is a theorem in this chapter. Theorem 1, it's called BPT, abbreviated as Basic Proportionality Theorem or Thales Theorem. So let's see what it says. So it says, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. So what is given in the theorem is just nothing but a triangle ABC is there, in which a line parallel to the side BC intersects the other two sides AB and AC at D and E respectively. Okay, and we need to prove that AD by DB will be equal to AE by AC according to this particular diagram. Okay, now there is a construction here. Join BE and CD and then draw DM perpendicular to AC, this line DM which is perpendicular to AC, and similarly EN line which is perpendicular to the side AB of this triangle ABC. Okay, now proof. Let's look at how we prove this. So these are the two columns we have, one for statements and the other one for reasons. Okay, so in the figure we have the area of triangle ADE is nothing but half into AD into EN, because we have already know that area of a triangle is half into base into height, right? So that's the reason area of triangle ADE will be equal to half into AD into EN, and this area of triangle AD is denoted as AR of ADE. Okay, and it is read as area of triangle ADE. Okay, now similarly if you take the triangle BDE also, the same thing happens. It's again the formula for area of a triangle. It's going to be half into base into height, half into base into height, right? So also we have this area of triangle ADE is nothing but half into AE into DM, and area of triangle DEC if you take, again it's nothing but half into EC into DM. Now consider the ratio of these two, that is consider the ratio of area of triangle ADE by area of triangle BDE, that is half into AD into EN, this value, and then divide by this value, that is half into DB into EN. Everything gets cancelled out and what remains is just the ratio AD by DB, and we call it as equation number 1. Okay, now also we have considering other set of ratio, we get this area of triangle ADE by area of triangle DEC we are considering. Okay, so that is half into AE into DM whole divided by half into EC into DM, which is equal to AE by EC. Everything gets cancelled out and the remaining is AE by EC. We call it as equation number 2. Now we have that area of triangle BDE will be equal to area of triangle DEC. This is our equation number 3. Why? Because both these two triangles are on the same base DE, and between the same parallels, which is BC and DE, Okay, that's the reason the areas of these two triangles are one and the same. So from the triangles, from the equations 1, 2 and 3, we can directly conclude that AD by DB will be equal to AE by AC. Because these two ratios are equal, we can see that AD by DB will be equal to AE by AC. Okay, this completes the proof. And now going to the second theorem in this chapter called converse of Thales theorem or converse of BPT. Okay, so let's see how we prove this. So it says that if a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So what is given in the theorem is just nothing but a triangle ABC in which DE this line DE is parallel, DE is the line such that this holds good, that is AD by DB will be equal to AE by EC, and we need to prove that DE is parallel to BC. So the construction we made is draw a line DE dash which is parallel to BC. Okay, proof. So firstly, let us assume that DE is not parallel to BC. So if DE is not parallel to BC, then let another line be there called DE dash. Okay, let it be parallel to BC. We'll assume like this, and therefore, according to Thales theorem, what we get is AD by DB will be equal to AE dash by E dash C. AD by DB will be equal to AE dash by E dash C according to Thales theorem. This is from equation number 1. Hence, AE by EC will be also equal to AE dash by E dash C. This is given because if AD by DB is equal to AE by EC, whatever the value of AD by DB will be there, that will be equal to AE by EC also, right? So that's the reason these two are equal to each other, equal to this ratio AE dash by E dash C. This is our equation 2. Now adding 1 to both sides of equation 2, what we get is AE by EC plus 1 plus AE dash by E dash C plus 1. Okay. Now taking the LCM and simplifying, we get this AE by EC, that will be equal to AE dash by plus E dash C divided by E dash C, which implies that according to the diagram, if you carefully look into it, AE plus EC will be equal to the whole length AC, correct? And that is substituted over here. And similarly, AE dash plus E dash C will be again equal to AC, right? So AC will be cancelled on both the sides, and after cross multiplying, what we get is the value of EC will be exactly equal to E dash C. This is your equation number 3. So from this equation 3, we see that E and E dash must coincide. Without coinciding, there is no point of proving that these two are equal, right? So we see that E and E dash must coincide. Hence, our assumption that DE dash is parallel to BC must be wrong. Therefore, we conclude that DE must be parallel to BC. So this is how we prove the converse of Thales theorem. Okay. The next theorem 3 is about AAA. It's about angle similarity criteria. So the statement says if in two triangles, there are two triangles firstly. Okay. So if in two triangles the corresponding angles are equal, then their corresponding sides are in the same ratio, and hence the two triangles are similar. So what is given in the theorem is about the two triangles, namely ABC and DEF, such that angle A and angle D are equal, angle B and angle E are equal, and angle C and angle F are equal. Okay. Now what we need to prove is that AB by DE is equal to ABC by EF is equal to AC by DEF. That is the ratio of the corresponding sides of these two triangles are equal. We need to prove. Okay. So now construction. So cut DP is equal to AB, DP is equal to AB, and DQ is equal to AC. Okay. And join PQ in the triangle DF. So since this is the bigger triangle, we can cut the points P and Q here and then join this line PQ. This is what the construction will do. Okay. Then the proof is very simple. See, in the triangles ABC and in triangle DF, they have given that angle A is equal to angle D, angle B is equal to angle P, and also angle C is equal to angle Q. All these three are given the theorem, right? Then, therefore, since these three are equal, we can easily say that triangle ABC is congruent to triangle DPQ. Okay, because of by construction we'll cut these points P and Q and join this line. By joining that, we'll get these three angles which are equal, and hence by AA similarity criteria, by AA congruence criteria, we can easily say that these two triangles are congruent to each other. Okay, and now hence angle B and angle P is equal to angle E. Angle B and angle P and angle E, all these angles are equal, and PQ is parallel to EF because of simplicity, right? And now since these things happen, we can easily say that DP by PE, so this one DP by PE will be equal to dq by qf, and that is further dp is nothing but ab here, so you can directly substitute it, substitute as dp in place of ab. Okay, so ap by de will be equal to ac by df. Okay, and this is by Thales theorem, this is by bpt. And similarly we have ab by de will be equal to bc by ef, and hence all these three are equal. AB by D is equal to BC by EF is equal to AC by DF. Hence the proof. This is how we can prove the theorem 3, that is AAA similarity criteria. We'll go to the next theorem, theorem 4. It's called the areas of similar triangles. Let's see the statement of it. Okay, the ratio of the areas of the two similar triangles is equal to the square of the ratio of their corresponding sides. That is, given two triangles ABC and PQR such that they are similar to each other, that is triangle ABC is similar to triangle PQR. Okay, now what we need to prove is the ratio of area of triangle ABC by area of triangle PQR will be equal to the square of the ratios of corresponding sides, right? So AB by PQ the whole square is equal to BC by QR whole square equal to CA by RP the whole square. Now construction. So what we do is draw altitudes AM in this triangle and PN in this triangle, which is perpendicular. That is, altitude means perpendicular height, right? So for the triangles ABC and PQR respectively. After this, let's see how we prove this. Yeah. So we have this area of a triangle ABC as half into base into height formula. Okay. From that triangle, from that formula, we get this area of triangle ABC, and area of PQR is like this. Okay. And now considering the ratio of it, we get area of ABC by area of PQR will be equal to, so this value divided by this value will give us half will get cancelled. The remaining term is just BC into AM divided by QR into PN. This is our equation number 1, right? Now in triangles ABM and PQN, if you consider the statements, what we can see is angle B is equal to angle Q. Okay, similarly angle M is equal to angle N. See, angle B is equal to angle Q because these two triangles are similar. We are already given in the question, right? And angle M and angle N are equal because each angle is equal to 90 degrees. Since these two angles are equal, we see that triangle ABM is similar to triangle PQN. Okay, because of AAA similarity criteria, and therefore we can actually divide by using CBSE. AM by PN is equal to AB by PQ, which is our equation number 2. Also, we have also that triangle ABC is similar to triangle PQ, right? That's the reason we can write it as AB by PQ is equal to BC by QR is equal to CA by RP. This is our equation number 3, and therefore this ratio, if you consider it again, area of triangle ABC divided by area of triangle PQR will be equal to AB by PQ into AM by PN, right? So AM by PN is as it is. Instead of BC by QR, we are just substituting the values which are equal, that is AB by PQ. Okay, and now again AM by PN is again equal to AB by PQ itself. So AB by PQ into AB by PQ will be equal to AB by PQ the whole square. So by using equation 3, if one ratio is equal to this ratio of areas of the triangles, then it means that all the three are equal to each other, right? So we conclude that area of triangle ABC divided by area of triangle PQR will be equal to AB by PQ the whole square is equal to PC by QR the whole square, and that will be equal to CA by RP the whole square. Next we'll go to the other theorem called, one of the most important theorem is called Pythagoras Theorem. Okay, so what it says, in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay, so given what is given in the question, I mean in the theorem, a triangle ABC in which it is right angled at B. So it is right angled at B here. Okay, in this diagram. So we need to prove that AC square equals AB square plus BC square. If you keep this B as right angle, then AC will be its longest side. So longest side square is equal to sum of squares on the other two sides, that is AC square is equal to AB square plus BC square. Then construction, what we do is we just have to draw a perpendicular line, that is BD, which is perpendicular to AC. Okay. Now let's see how we prove this theorem. So in the figure we have seen that area of the triangle ADB is similar to triangle ABC. Okay, and hence we from the BPT we see that we have AD by AB will be equal to AB by AC. By cross multiplying we get AD into AC will be equal to AB square. Okay, that's our equation number 1, because the sides are on the same ratio. And the same way, if you are going to consider these two triangles, triangle BDC and triangle ABC, we see that they are similar to each other, and since they are similar, their sides are in the same ratio. Hence we can write it as CD by BC will be equal to BC by AC. That is, if we are going to cross multiply it like this, CD into AC will be equal to BC square, which is our equation number 2. And now adding equations 1 and 2, we get AD into AC plus CD into AC will be equal to AB square plus BC square. And in these two terms, taking AC as the common factor, what we get is AD plus CD, that will be equal to AB square plus BC square as it is. And then according to the diagram, if you are going to look at the sum of AD and CD, it's exactly equal to AC, right? So that is substituted here from the diagram. Okay, so AC into AC will be equal to AB square plus BC square. And finally what we get is AC into AC is AC square will be equal to AB square plus BC square. So hence the proof. This is how we prove Pythagoras theorem. Now let's look at the last theorem of this chapter, theorem 6, which is called the converse of Pythagoras theorem. Let's see what it says. So it says that in a triangle, if square of one side is equal to the sum of the squares on the other two sides, then the angle opposite to the first side is a right angle. So this is quite the opposite way of saying the Pythagoras theorem, right? So given what is given in this theorem is just nothing but the triangle ABC. There is a triangle ABC in which AC square is equal to AB square plus BC square. This holds good. Okay, now we need to prove that angle B is 90 degrees. See in the these two diagrams, we see that angle B, we are not specified whether it's 90 or not, but in this triangle we have specified that angle Q is a right angle, right? So carefully we need to observe these things. And then construction is, what we do is we take one more triangle PQR, which is right angled at Q, such that PQ and AB are equal, and similarly QR and B, the baselines are equal. Okay, now let's see how we prove this. So from the triangle PQR, we have that PR square is equal to PQ square plus QR square. That is, from the Pythagoras theorem we can be able to write like this. Okay, or in the next line we can also write it as PR square will be equal to AB square plus BC square. This is from equation number 1. By construction we know that PQ and AB are equal, and similarly QR and BC are equal, right? So we can substitute one in terms of another, right? So that let me call it as equation number 1. And now but according to the given data, what we have AC square is equal to AB square plus BC square. Let me call it as equation number 1. This is given in the theorem. Okay, hence AC will be equal to PR. See, since in these two equations from 1 and 2 both right hand sides are equal, hence we see that both left hand sides should also be equal, right? So AC equal to PR. Let me call it as equation number 3. Now in triangle ABC and in triangle PQR, if you are going to consider these two triangles, we have AB is equal to PQ, that is by construction, right? And similarly we have BC is equal to QR, it's again by construction. Okay, and also we have AC is equal to PR, that is proved already here in equation 3 above, right? So since all these three corresponding sides are equal, we can say that according to SSS congruence rule, these two triangles are congruent to each other. So triangle ABC is congruent to triangle PQR. Therefore angle B is equal to angle Q. This is from CBSE. but angle Q is equal to 90 degrees by construction we have, and hence since these two angles are equal, we can also say that angle B is equal to 90 degrees. Hence we have proved that angle B is a right angle. So triangle ABC is a right angle triangle, right? In which it is right angled at B. So hence the proof. This is how we prove the converse of a Pythagoras theorem. Okay, and then lastly, the illustrations we have. Just look at it. Illustration 1. We have in this particular figure, we have this triangles BDC is similar to triangle ABC. Then BC square is equal to dash, they are telling. So what is this? BC square will be equal to which among these following options are equal? We need to choose the correct answer. Okay. Now, what is the if these two triangles are similar, then according to Pythagoras theorem, according to BPT, we can actually divide the corresponding sides and then cross multiplying. After all those things happen, we get BC square will be equal to AC into CD, and that is present in option A. So option A is our right answer. Right? BC square will be equal to what? AC into CD. AC into CD. Now, we'll have this one more illustration too. That is, if A square is equal to B square plus C square, this is from Pythagoras theorem. They have written like this. Okay, then the value of C is we just have to solve for the value of C and tell which among these four options is the right answer, right? So obviously A square, B square, if you shift towards left hand side, it becomes minus B square. So C square will be equal to A square minus B square, and then C will be equal to plus or minus root of A square minus B square. I think it's option C, right? Yes, it's option C, that is plus or minus root of A square minus B square. So this is our right answer, right? So this is how we can solve these one mark questions and all MCQs, but very easily. Thank you. We'll get back to you with this revision of next chapters.